Okay, good morning. Welcome to
SuperMath111.
SuperMath111. So we had a cool problem in the review section of your geometry book this morning. And it just said, here's a regular hexagon, which I haven't drawn quite right, but maybe close enough. And it said, I want you to find the ratio of this diagonal to this diagonal, or maybe it was the other way around, this diagonal to that diagonal.
Yeah, it was the long one to the short one.
Okay. All right. Great. So we talked through it, but I'd like you to explain it.
Well, just to make things easier, I'm going to have the side of the regular hexagon be 2.
Okay. Why did you pick 2 instead of 1?
Well, because I'm not sure if we have to divide this in half or not.
Okay.
So, and if it turns out we do, 2 is a lot easier to divide in half.
Oh yeah?
Than 1.
How come?
Well, it's easier to work with.
Yeah, that's true. It is easier to work with.
So I'm going to draw this diagonal. It has the same length as this diagonal.
Alright.
And there's a bit of angle chasing I can do. So I know the angle in a regular hexagon is 120. And these are both 2, so this is 30. 30. And this is 90. And do the same thing up here.
To say, I'm not sure why that would be 90.
Well, because you have to, this is an 120 degree angle as well.
Oh, okay.
So you need to add up to 120.
I gotcha.
Do the same thing up there. So now we have some congruent triangles. Maybe this will help, but this triangle here is congruent to this triangle here.
Okay.
Because they have that angle in common, they share this side, and they have that side in common.
Okay.
So that means this angle is that angle. This angle is that angle. Well, actually now, there's a sneaky shortcut. I didn't actually solve it this way, but I'm noticing it just now.
Okay, cool, that's fine.
So, this has to be 60 because this angle is 120.
Ah, and you have congruent triangles.
So this is 30 and 30. Then you have a 30, 60, 90 triangle.
Okay.
So this is 2 root 3. And this is 4. So, and this is 2 root 3. So our ratio is 4 to 2 root 3. Or 2 to root 3.
Okay, super. Hey, very good job. I was almost high-fived the wrong hand. One other thing I just wanted to point out. On a regular hexagon, remember how you can divide a regular hexagon into 6 equilateral triangles?
Yeah.
1, 2, 3, 4, 5, 6. So this long diagonal goes through the center of the hexagon. It's sort of by symmetry, right?
Yeah.
And because you can divide this into 6 hexagons, you know you got 2 lengths of each equilateral triangle here. So you could approach it by chopping it up into 6 regular equilateral triangles. And you would then know this was 4, that was 2, and that was a right angle. So you could know right off the bat that that was 4. Well, not, almost right off the bat that was 4. That would be a different geometric way to approach it. But your way's great, by the way. And then finding those congruent triangles and then noticing that you had 60 and 60 there, which you didn't notice the first time around. So that's a great thing to notice. What did you do the first time around? Do you remember?
Well, I dropped a perpendicular here.
Uh-huh.
And then I had a mini 30, 60, 90.
Okay.
So this was root 3. So then you had 2 of them, so this was 2 root 3, and then I was able to figure it out.
Then you were able to figure it out. It was 4. Okay, super. Good job, huh? Good job this morning.